Alright, hello once again. This is Jeff Scott of Rankin Technical College, and I've been going over, or re-lecturing, if you want to call it that, on Chapter 12 for our C# 2015 book, which is part of the AWD1100 C# programming class. I've gone through all of the chapter, but I want to make sure we talk about a few things, and hopefully that they'll become clearer or clearer to you. Alright? The first thing is a method. When you look in here, this is a method, this is a method. Technically, these are methods. I probably wouldn't be called that. This is a method, and this is a method. So what is a method? A method is code that's designed to complete a single task. In non-object oriented code, a method is basically a function. And what happens is, by using methods, we are able to hide from the user the actual task that we're performing. And now that actually should make some sense to you. We talked before about interface and implementation. The interface that the user sees for this, alright, that interface when we run the program is just that list box, and that is using the get display text to add the 3 or 4 records, the product code, price, and the product name. The implementation, or as far as how that's done, doing this, is of course hidden from the user, and it's hidden from the user because there's no reason for them to know about it or see it. Now, when we jump back up to the top here, the name of this class is product. Okay? A class is also looked at like it's a blueprint. So imagine that I was going to build a new house and I bought the lot. Chances are pretty good I wouldn't just have somebody come over there and start, cutting into or using a bulldozer or whatever to clear ground. I'd probably want to get an architect first to come in and tell me what it is they're planning on doing, how it is they're planning on doing it. That would be the blueprint for my house. That would be the class. The actual house that we create, that would be the object. All right? Now, let's not talk about a class. Let's talk about something, maybe a car when you drive. All right? So when you drive a car, you just know how to do things. You press a gas pedal and, you go faster. You hit the brake pedal, you go slower. How is all that done? Well, basically, you're sending messages to the car, to the internals of the car as far as what to do. In much the same way, you send messages to an object, and each message that you send is a method call. So if you tell that object that what you want to do is display its text, boom. If you don't send it anything, that's what it does. If you send it a separator, that's what it does. All right. Now, if you talk about a car analogy, which we have been doing, and we talked about, you could have a car class, you could have car objects, you could have car methods. All right. And each car also would have its own instance variables. In other words, it would have its own color, 4 doors as opposed to 2 doors, a hatchback as opposed to a non-hatchback, how big the gas tank is, etc. Those are all would represent instance variables, all right, for the car class. And collectively, they're known as the attributes for the car class. Finally, again, we talked about this, that you've got your get accessors and your set accessors. With a get, all right, then the name of your property is on the right-hand side of an equal sign. You are grabbing that information that already exists, and typically you're assigning it to something else. On the other hand, when you use a set, it's the name of the property is on the left-hand side of the equal sign. Because again, you are literally setting a property. All right. Now I'm going through and I've got my own notes and a bunch of other stuff in here. And it's going to be interesting because, again, part of what I'm charged to do here is to get you through a certain number of chapters. Okay, we've talked about this before. And you are, when you come back, you are to finish um, by Friday, which is going to be the 20th. I want you to do those problems that we did from the Chapter 12 lab. We do them in a non-object oriented way. All right. And what I'm going to have to do, in addition to these things I'm putting up here, is to go back and do one or two of those problems in an object-oriented way. Those will be due the next week. In other words, those will be due on the 27th. All right. And probably before the 27th, we're going to need to have a test in there. And that test will be on Chapter 12. After that, we'll go through Chapter 13. And I'm about to start the lecture on that in just a minute. It's on inheritance. And when we go through the lecture for Chapter 13, after that we'll have another test. All right, then we'll go and cover, I'm sorry, not 13, it'd be 14. I'm skipping 13. Then I'll do 15 and 16, and I'm not even going to test you on those. I'm just going to go over them. Then we're going to jump into the database stuff, and I hope to put all this together by having us work on some kind of a class project. I'm still looking into that right now. Okay? All right, so let's see, what do I have here? I've got some examples, but again, they're very much mirroring what we've already done. All right, so I don't want to spend a lot of time talking about those. Okay. So this whole section that I've got some of my own notes on. I'm not going to do anything with it, at least right now. Let's see. One last thing to talk about in here, and that is the idea of something being static. All right, I believe we have talked about this before, but let's say that I'm going to get rid of this right away. But let's say I came in and put in another method here that said public void divide numbers, and I'm not going to pass anything in there. All right, so I'm going to come in here and I'm going to say this. I'm going to say int x equals 37, int y equals 3, int z equals x divided by y. You're all smart enough. You all know how to do this. Now, if I come through here and I bring in the calculator, I want to do that. Let's bring it up here. And I say that what I want to do here is 37 divided by 3. Well, you see the answer I get, 12 with a boatload of 3's. Now, if I don't want that, okay, I can say, for example, z equals math dot round. I thought that's what it was. All right, something like that. In fact, maybe I can do it like this. Let's try it here. All right, and that's what I want to do. So let's see. Show fixes. Using system. So I have to add a using system up on the top here, which I don't currently have. And once I've done that, okay, and no, all right, and it's telling me call is ambiguous between the following methods and properties. let's make all these doubles, and that's fine. So double X, double Y, and double Z. Alright, because what I'm trying to show you here is that we're able to use from the math class, we're able to use the round method without having to create an instance of the math class. The math class is a static class, which means that it is available to basically every program that needs it. And the methods from there are the same. Alright, so you notice, or maybe you noticed, that when I did the math dot, came up with a whole bunch of stuff. There's square root, there's absolute value, there's a bunch of trigonometric functions, etc. So there's a lot of ways in which this can be used. And that's what I wanted to get across to you right there. Just talking a little bit about, literally, about using static, because anything can be static, basically. Variables can be static, methods can be static, classes can be static. Alright? Now I do have another example that I want to run through here with you before we go on. I don't know how long it's going to take, so I'm going to pause right here, get my act together and get my notes together. We're going to come back and we're going to start writing our own classes, and we'll do that in just a couple minutes.